In this video, let's explore decoders. Specifically, we will focus on binary decoders. A decoder is a combinational logic circuit. It converts an n-bit binary input into 2 raised to the power of n unique output lines. Now let's explore different types of binary decoders. The first one is a 2 to 4 decoder, which has 2 inputs and 4 outputs. The second one is a 3 to 8 decoder, which has 3 inputs and 8 outputs. Let's understand the working of a 2 to 4 decoder using a truth table. In this table, A1 and A0 are the inputs and Y0, Y1, Y2, and Y3 are the outputs. When both A1 and A0 are 0, Y0 is active, meaning it is 1 while all other outputs are 0. When A1 is 0 and A0 is 1, Y1 is active and the rest are 0. When A1 is 1 and A0 is 0, Y2 is active and the others are 0. Finally, when both A1 and A0 are 1, Y3 is active, while the remaining outputs are 0. Here are the logic equations for a 2 to 4 decoder. Y0 equals A1 bar multiplied by A0 bar. Y1 equals A1 bar multiplied by A0. Y2 equals A1 multiplied by A0 bar. And Y3 equals A1 multiplied by A0. Here is the circuit diagram for a 2 to 4 decoder. The circuit consists of 2 inputs, A1 and A0, which are connected to NOT gates to produce their complements. The outputs of the NOT gates and the original inputs are then fed into 4 AND gates. Each AND gate corresponds to one of the 4 outputs, Y0, Y1, Y2, and Y3. These AND gates decode the input combinations to activate the corresponding output. The truth table for a 3 to 8 decoder has 3 inputs, A2, A1, and A0, and 8 outputs, Y0 through Y7. Each row of the table represents a unique combination of inputs, and accordingly, only one of the 8 outputs is active or high represented by a 1, while all the other outputs are inactive or low represented by a 0. Here are the logic equations for the 3 to 8 decoder. Y0 equals A2 bar multiplied by A1 bar multiplied by A0 bar. Y1 equals A2 bar multiplied by A1 bar multiplied by A0. Y2 equals A2 bar multiplied by A1 multiplied by A0 bar. Y3 equals A2 bar multiplied by A1 multiplied by A0. Y4 equals A2 multiplied by A1 bar multiplied by A0 bar. Y5 equals A2 multiplied by A1 bar multiplied by A0. Y6 equals A2 multiplied by A1 multiplied by A0 bar. And Y7 equals A2 multiplied by A1 multiplied by A0. Decoders have a variety of applications in digital systems. 2 primary applications are memory selection and 7-segment displays. In memory selection, decoders are used for address decoding in random access memory and read-only memory systems. For 7-segment displays, BCD to 7-segment decoders are used for digital displays. If you like this video, hit that like button and don't forget to subscribe. Visit CodeLucky.com for more such useful content.